Hello and welcome to today's video. Today, I'll be addressing a concern raised by one of my students on occupational radiation exposure. How safe is being a radiation worker? I think this is also a good time to inquire on the propriety of disclosing the names or identity of people that ask questions that are being addressed or discussed. So please go to the comment section and let me know whether you think it is proper or not right to disclose the identity of people from the comment section. Also, be kind enough to spare enough time to explain your reasons for your opinions for or against the disclosure of identity. That will educate and enlighten me better on what to do. Remember, we're learning from each other. So please do me the favor, go to the comment section and let me know if you think it is right to disclose the name or identity of the people asking questions in the comment section or not. Thank you as you do that. Okay, so let's dive into today's topic. How safe is it to practice as a radiographer? To start with, are you also a radiography student wondering how safe it will be to practice as a radiographer? If you are, then be consoled you're not alone that has the question. I believe the knowledge that you're not alone in this concern or query is calming enough. Sometimes, just being able to air out our honest concerns and fears can be greatly unburdening and rewarding as well. After all, how else can we find ways to allay our fears if we don't ask the right questions or seek knowledge? Robin S. Sharma once said that we fear things in proportion to our ignorance of them. In essence, we only fear things we truly do not understand. So let's start with some consoling facts. Radiation safety in medical imaging as compared to other professions is one of the most rigorously managed occupational exposures to radiation. And this is based on decades of science, international regulations, and cutting-edge technology. Happy, right? Okay, let's take a deep breath and break down the facts. So yes, it is true that radiation workers get exposed to some amounts of radiation in the course of discharging their duties as radiographers, what is termed occupational exposure to radiation. And according to ICRP, the International Commission on Radiological Protection, a dose of 20 millisievert per year, averaged over a 5-year period, as well as a cap of 50 millisievert in any given year, is considered safe. Sounds complicated, right? Okay, let's break down the numbers. 20 millisievert per year, average over a 5-year period, simply means that radiation exposure must not exceed a total of 100 millisievert over a 5-year period, because the average is equals to the sum divided by the total number of frequencies. So if you have accumulation of radiation over 5 years to be 100 millisieverts, dividing it by the 5 years gives you the 20 millisieverts on an average every year. So for example, let's take a radiographer working for a period of 5 years, which would label as year A, B, C, D, and E, representing 5 years. Now, let's assume that in the first year, which is year A, the radiographer was exposed to 15 millisieverts of radiation, then 20, and then 15, and 22, and then 25 millisieverts, totaling 100 millisieverts for the 5 years. Taking an average of that over the 5 years will give us a 20 millisievert per year. That is within the safety margin of the research done by ICRP, which we'll discuss later when we come to discussions about safety margins. And let's go to the second part of the recommendation, which says a cap of 50 millisievert for any given year. Now, if you notice from the example we gave where we have years A to E, each year has a unique value for the radiation dose. You have a 15, 10, 20, etc. But in each of these years, the idea is that no year should have a dose that is more than 50 millisievert. So no matter what exposure, no matter what the variation will be across the years, there shall not be any year in this 5-year period that has a dose that is more than 50 millisievert. The simple reason is because that will fall still within the safety limit of the 100 millisievert that has been shown by research to be the value for which observable radiation effects can be noticed. The 50 millisievert cap also ensures that no exceeding or dangerously high radiation dose is received in any year that would come close to not even reach the value for observable radiation effects to radiation. Now, you may at this point want to know, okay, how would these values be achieved? How are we sure that it does not get exceeded? How are we sure that as radiographers, we are working within this limit? Now, there are strategies that have been put in place already to ensure the safety of radiograph. And first of all, that the diagnostic room is engineered for safety. The lead lining of the room, then the use of lead aprons, all form the structural protective mechanisms that is supposed to protect the radiographer from excessive exposure to radiation. The radiographer's exposure to radiation is also monitored. There are usually those monitoring devices that are given to radiographers, whether it's the TLD, the OSD, or whichever way, or the pencil OSD that is being used. It is essentially given to radiographers in order to record the dose that a radiographer receives, and then also to help in the monitoring to ensure that the radiographer does not exceed the dose limit. Furthermore, as part of your training as a radiographer, one of the cardinal things you are taught in training is the principle of ALARA, as low as reasonably achievable. Although it is believed that stochastic effect can happen at any dose of radiation, however, the cumulative effect of radiation and even the stochastic effect of radiation is dependent on what you call the linear non-threshold effect, meaning accumulation of the doses can actually lead to an effect. So as long as you practice within the acceptable ALARA principle, it is believed that your chances of exposure to radiation are kept to the barest minimum. In addition, you are not alone in your safety as a radiographer. You're supported by international organizations like the IAEA, the ICRP, the NNRA, and etc. that are responsible for ensuring that either the strategies or the regulations are maintained and adhered to by either institutions or to control your practice as a radiographer. So you can see there's a robust mechanism that has been kept in place to ensure that radiographers are protected when they use radiation as part of discharging their duties. At this point, I think it will be a good idea to go down memory lane and look at some milestones that have informed the current 20 millisieverts and an average of for 5 years, or the 50 millisieverts caveats. And what better place to start at that from the discovery of X-rays. As we all know, X-rays were discovered in 1895 by William Conrad Roentgen. Now, about a decade after the discovery, like every other new thing or any other novel discovery, there was a flurry of activities around it, and everyone was interested in using this new radiation called X-radiation, in as much as their intent was to do good with it. However, the hazardous effects were not known then, and so there was a wide, uncontrolled use of this radiation. This led to several sicknesses and even deaths of several people that used the radiation. Now, it took the death of many radiologists and scientists for International X-ray and Radiation Protection Commission to be formed. The formation of that brought about the first set of guidelines for occupational exposure, which is set to be at around 500 millisievert. Now, let's look at even the highest limit we gave that was acceptable of 50 millisievert, and what they accepted as a permissible dose of 500 millisievert for radiation workers. Now, this was based on observable effects, which were greatly deterministic in nature. Most radiation effects are known to start manifesting at around the 500 millisievert, as according to their research, based on the science that was available and data as at then. But it is currently discovered that even some deterministic effects can start manifesting from 100 millisievert. So they bet their occupational permissible dose to be 500 millisievert, significantly higher than the 20 millisievert acceptable current. In following the effects of the bombings of the World War, the Hiroshima and Nagasaki also nuclear explosion, observable effect of radiation became more than just deterministic effects. Then the concept of stochastic effects came into being, that some effects of radiation can occur at significantly lower doses than was accepted initially as part of the first recommendation. So in order to minimize this stochastic effects of radiation, the ICRP came up with a new benchmark for occupational radiation exposure to be 50 millisieverts per year, which according to the books by now is the maximum allowed, but not the generally allowed. It is the maximum allowed for any given year. Now, the refinements of the 1990s to the early 2000s, it gave birth to what we now know as the ICRP recommendation that was given in 2007, 20 millisievert average each year over a period of 5 years, and the 50 millisievert cap for any given year, for any given single year. Okay. Now that we're familiar with what the occupational radiation dose is, now that we know how it came about, and now that we know the rationale behind it, can we now ask the question of how safe is this 20 millisievert average over a period of 5 years, or the 50 millisievert cap is in any given single year? How safe are those values really? Now remember, I've been talking about safety margins right from the beginning of the video, and I did say we're going to discuss more about it. There are several reasons why scientifically the 20 millisievert average over 5 years and the 50 millisievert cap for any given single year is safe. First on the list will be the fact that this came from a wide data that was obtained from survivors of bombing, medical radiation workers over time, nuclear radiation workers over time, that have been collected by organizations like ONSCARE and the ICRP. And their studies, after several data collection, arrived at the point that observable effect of radiation, stochastic or deterministic, are usually only observed from a threshold of around 100 millisievert at exposure. So that technically means that from the 100 millisievert to 20 millisievert is a gap of 80 millisievert, considered a wide safety margin, wide enough to offer safety or proffer safety to a radiation worker. So that is first on the list for why the 20 millisievert is considered safe for a radiation worker. Now, the next reason why you would want to believe the 20 millisievert average over 5 years and then the 50 millisievert cap is to compare it with the already determined threshold for deterministic effect of radiation. Science has shown that effects like cataracts can start from around 500 millisievert, but current data says that in fact cataract can start as low as 100 millisievert. But the bottom line is that deterministic effects like cataract or skin erythema, which is one of the commonest effects of radiation, starts usually at around a dose of 2,000, at around doses of 2,000 millisievert. You can now see that you require tens and hundreds of this occupational radiation exposure in order to be able to achieve that, which clearly also points to the fact of the safety margin being wide. Comparing this occupational dose limit to natural background radiation, some areas like Ramsar in Iran and Kerala in India exposed people to dose of radiation of about 10 to 20 millisievert with no observable effect. And that also points to the fact that 20 millisievert can actually be a good value to be safe at as a radiographer. Now, comparing the 20 millisievert per year and 100 millisievert over 5 years to the 100 millisievert relative cancer risk, it is observed that at 100 millisievert, there's a 0.5 to 1% chance of having cancer or risk of having cancer. And if you look at the lifetime journey of a radiographer, which will span from 25 to 30 years, it simply means that theoretically they can accumulate up to like 500 millisievert of radiation, and that will only increase the cancer risk to about 2 to 3%, significantly lower than other professions like firefighting, air travel workers, like people that work in mining or manufacturing. The risk for cancer of radiographer is significantly low than those other professions. So in conclusion, the 20 millisievert average over 5 years, totaling 100 millisievert, is not risk-free. However, it is based on robust science, aligned with acceptable international standards, and designed with a wide safety margin, very conservative safety margins, also supported by global international standards. So I hope with these few points of mine, I've been able to. Please pay me no heed. I remember the good old days of debating. But I do hope that from now, we will be able to strut into our profession currently or in the future with zest and professionalism to discharge our duties, confident that we are safe. So stay curious and stay safe. It's bye.